Okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. So today the date is November 13th. The time is 10:46 a.m. Eastern Standard Time on my side of the world. We have with us Muhammad Rowaim Safdar. Uh, he is going for his diploma in artificial intelligence operations, EduQual level 6, RQF level 6. The topic is building resilient edge AI infrastructure with K3s, OpenFaaS, and NATs for smart manufacturing IoT. You mentioned that you are at Huawei, right?
Yes.
This is their wheelhouse, edge AI infrastructure. This is what they do, right? I'm not sure like what they're doing in Pakistan, where you are right now, but normally, like
R&D side.
R&D sites and other countries, they're doing a lot, right? In the IoT and all of those things. Recently, uh, I started looking for a car to buy, right? So when my son was at the hospital yesterday, uh, I was having a discussion with him on Tuesday. I was having a discussion with him. So he showed me Huawei car, right? It's a amazing car. It's a Huawei
Extro.
luxury. Have you seen it? Have you seen it like there?
I saw the video.
It's amazing. Like, I mean, the car was like, I mean, I was blown out of the world. Like, what is this, right? So something that we will talk about. It's known as Maxtro, right?
Right.
Maxtro. So they are jumping into mobility. They are jumping into all of those things, but that requires IoT infrastructure because it's all Internet of Things, right? So you're collecting data from all the sites and everything. If that car, which is, I believe, $90,000 to $100,000, that beats Bentley, that beats all other cars, even the high-end models of Tesla, which is, I mean, I've, I had the opportunity of not driving Tesla, but I had the opportunity of sitting in Tesla multiple times when I was using Uber. So I selected Tesla to see, and it's a bare bone car. Even I sat in the upper end, high end Teslas as well. It's the same thing, right? So I didn't like Tesla Drive and all of those things. So what I'm seeing is like the Chinese are really breaking new ground, right? And Huawei is a giant. It's a huge company, right? Okay, so that's good. So the topic that you have, it covers the building resilient edge AI infrastructure for K3s, OpenFaaS, and NATs for smart manufacturing IoT. It has multiple objectives: edge computing architecture, serverless edge computing, distributed messaging and data synchronization, AI ML at the edge, industrial IoT integration, resilience, and fault tolerance, right?
Right.
It covers multiple open source tools like for edge, Kubernetes is K3s, Admiral, Longhorn, serverless OpenFaaS, Knative, messaging, NATs, Eclipse, Mosquito, AI ML, again, multiple things, PySoft, MLflow, all of those things, resilience, OPC, UA, MQTT, Modbus, all of these things, right? For the presentation, you will be given minimum 15, maximum up to 20, 25 minutes. Please keep it short. Don't go, long. I'm not looking for a massive long presentation. I'm trying to understand if you can demonstrate to me all the core objectives, the learning objectives of the presentation, the key learning objectives, followed by a Q&A that will last from 30 to 40 minutes. Are you ready, Rowaim Safdar?
Yes, I'm ready.
You may share your screen. When I tell you to start, you may start. Okay, Bismillahir Rahmanir Rahim. You may start now.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum. My name is Mohammad Rowaim Safdar, and I am student of Artificial Intelligence Operations Diploma, which I am pursuing with the Nafi International College. So today I am here to present my final presentation topic, which is about the Edge AI, building resilient Edge AI infrastructure with Kubernetes, OpenFaaS, and NATs for smart manufacturing IoT. So basically, this architecture ensures that we build a system that is resilient, It means it handled the incidents autonomously, and it possessed the ability to withstand any failure. And we introduced the AI into this architecture. So the industry that I will be targeting for this example is the automobile industry. So let's get started. So this is the agenda for our presentation. Like, I will start with the problem statement with the current system, then I will come up with the solution, then a comparison between the cloud and AGI, and then the end-to-end workflow. We will go through the components, and after that we will check the main things like the resilience and the fault tolerance, the federation learning, and the multi-cluster federation. And at the end, we will go to the conclusion and the future work. So initially, let's start with the problem statement. Like, modern factories generate massive amount of data in the production system. So if we consider the current system, like, which heavily relies on the cloud, central cloud for the processing, but it comes with the different critical risk, like latency, the cloud dependency, the real-time decision, and the cost and the privacy risk. Let's go through them one by one. So let's say this is my robot, which is capturing the image of this car part or any product, and for the processing, it sends the data to the cloud for the processing. In the current system, it is very difficult because it involves the latency, because my data travels from all the way from this robot to the cloud over the network, which is very delayed, and it also possesses the cloud dependency. Like, it is a single point of failure. So if my cloud fails, then all of my system will stop. Also, it lacks the real-time decision making, since decision is made at the cloud. So it involves the latency. And also, it is very costly because all the video streaming on the images data is transferred via the this network to the cloud, which is very costly and also the bandwidth heavy. And it also possesses the privacy risk because the sensitive data of the production or manufacturing house leaves the company premises and move to the cloud. So this is the current issues with the traditional system. Now, what's our solution? Our solution for this problem is the hybrid cloud edge AI infrastructure. What does that mean? So if I explain it into a simple philosophy, it means that bring AI to the data, not data to the AI. So this simple concept means that instead of processing that whole data at the cloud, we bring the cloud processing to the right at the sensor or the robotic arm, which is generating the data, utilizing technology which is called edge AI or the edge computing. So our architecture is divided into three layers, which is the edge IoT layer, where edge device will be present for the processing, for the data processing. And second layer is the federation layer, which will be used to since we are dealing with the multi-cluster setup, like managing the different floors or the different regions of the factory. So this federation will be responsible for that part. And the end, which is the cloud, which will be used for the global model training and the long-term storage. So this is our architecture. So now these are the points that our architecture will solve. Like, it will solve the local decision making, since our edge device will be present directly with the device generating the data. So we will have local decision making, and also with low latency, because there is no network cloud dependency involved. And also the system will be resilient and autonomous, which I will describe in the next slide. How it worked in the resilience way and even without the internet. And the fourth point is it is very optimized for the cloud use, because in our system, all the data will be processed locally and only the processed result will be sent to the cloud. So it will save us huge cost for the cloud. And also the security, because security is very main concern for the manufacturing industry. So the sensitive data will stay local and not travel to the cloud. This is this is a comparison between the cloud and the edge AI. So all the points that I discussed previously, these are all just for the reference, like latency. Edge AI leads in the latency. Sorry, not leads in the latency. I mean, it improves the latency and the bandwidth use. It also has possess the ability to operate offline, even if the internet is not connected. and it also ensures the data privacy and resilience and scalability. Typically use cases, real-time decision making, and local control safety critical app, which is our main requirement for the IoT industry. So now let me walk through the end-to-end edge AI workflow, that how the data actually flows in this system, like from data moving from the sensors to the AI inference pod and the decision being made and the counter action based on this decision. So the story started with our sensors like physical devices, cameras or robotic arms, which captures the images or the vibrations of the machines, which they transfer it via the OPC UA protocol, which is a communication protocol used for the IoT industry, and it is translated by the Edge Gateway into the MQTT format. So this MQTT format is used to be ingested into the Mosquito broker. So this is our component Mosquito broker, which is a lightweight ingestion component. It is used for it is used for ingestion of low and low lightweight uh, protocol data or the input data. And further, this MQTT transfer this data to the Nets Jetstream platform. So it is a fault tolerant and event streaming platform, which also ensures the data persistence. So which is the key component for the resilience. And it works on the principle of the publish and subscribe model. It means that the Mosquito will publish the message to the uh, Nets certain topic like image data or certain kind of topic, and the Nets Jetstream will listen to that topic via subscription. So when the Nets Jetstream receive the data, it will eventually trigger the OpenFast function. So this OpenFast is a component which is the serverless computing open source platform and event-based platform. It means that it executes the code based on the event. So which also save our cost for the cloud and computing resources. So further, this OpenFast will provide that NATS data to the AI inference pod. These pods are hosted on Kubernetes, which is lightweight Kubernetes, and each will running the TensorFlow Lite model or the ONX runtime for the low latency inference. It means that it will these are the lightweight pods which will run the model, and based on this model it will take decision based for this data. So let's say consider the scenario that our data involves certain defect, like the weld quality is not up to the mark or some vibration is not abnormal, any kind of defect. Let's consider the scenario. So based on that, this inference pod will this open function will trigger this actuator via the MQTT command to perform the counter action, like stopping the conveyor belt or divert the defective part. And in the meanwhile, in the parallel, there are some of the components involved, like the influx DB, the telegraph, and the Grafana for the local monitoring and anomaly alerts. So the telegraph is a component which is used for collecting these matrices, like the OpenFast execution data, the timestamp data, the AI inference result, like whether the image is up to the mark or not. And these kind of data, it will store into the InfluxDB, which is a time series database. And this database will power the Grafana dashboard, which will be shown for the data visualization and monitoring locally on the plant. And now here our cloud component came into play, where the data will be synced with the cloud for the long-term storage and the global model training. And this thing will be performed by the component like the Admiral, MLflow, and Pi Sift. So this Admiral is a multi-cluster management agent, which coordinates the clusters, and it feed the data from the cluster via the using the PySwift open source framework via the aggregated learning, which means that it will get the model training data from the local edge site, not just the raw data, only the output result, like the output of the inference pod and all. It could be like the model new training data, like the model weightages or the gradient descent kind of new training data or any new learning pattern. It will only get that data instead of the raw data. And via the ML flow, it will perform its deployment and versioning. So the latest version or the new updated version of the model will be deployed onto the ML flow, which will then using the Safdar core light agent, it will wrap that new model as a service and collectively redeploy them onto the edge each cluster for continuous learning while maintaining the accuracy. So this is the end-to-end workflow of this edge AI architecture. Below are components that are used for the reference and the little definition of it. So this is the detailed architecture resilient diagram. This is the same thing that I discussed previously in the workflow, just the diagram and is much detail and showing each component. So the same story that I previously described is performing here, like the sensor devices generate the data via the OPC UA protocol or the legacy protocol, which is Modbus, and it will publish it to the MQTT broker. And this MQTT broker will ingest that data into the Nets Jetstream platform. So this blue dot is our Kubernetes, which is the key 3S lightweight Kubernetes component, and all of the components are there as a Kubernetes pod. And same thing, this Nets Jetstream will trigger the OpenFast function, which will eventually execute the TensorFlow model for the inference. And here one more component I would like to mention, which is the Longhorn storage. So basically this component we are using for the resilience and backup of the data. So this Longhorn storage, what it does, it stores the data of this OpenFast and this TensorFlow inference, and it stores it across multiple nodes. So if one of our node goes dead or some kind of issue, then it has the replica of the data across different nodes. And also the matrices are collected at the Telegraph, and via the InfluxDB, it is stored and it is shown as a Grafana dashboard locally for the monitoring and alerts. So this is the same thing. And the third layer is our cloud, as I described, that these all of the, once this data is this local model is trained, so this data will be collected by Admiral control plane, which is the agent uh, for the service discovery, and the which is used for the cluster fetching the cluster data. And this data, it will feed to the PySwift federation learning. So this it will perform the federated learning. So this federated learning means that the model is being trained from different remote edge sites and not on the raw data, but only on the process data. So in that sense, it preserves the data privacy, and only the updated model, it is version to the ML flow registry platform. Once the new version is up there, then it is stored into the long-term storage, and via the Safdar core light agent, it is again redeployed to all the cluster as a service. So that way, our system is both resilient and also it continuously learns from the data. So this is the slide where I group the component with respect to their function. So if we go with the orchestration and the federation, so we use the lightweight Kubernetes for the edge cluster, which is the lightweight version of the Kubernetes, which is built on a single binary. So means it is easy to install on the edge devices. And also we have the Admiral agent, which is the multi-cluster federation and federation configuration sync agent. And we have two of its component. One is the control plane, which is present at the cloud layer, and the other is the local agent, which is present at each edge side. And Longhorn is a distributed persistent storage for models and logs matrix storage. For the messaging and ingestion part, we have the sensors and cameras like normal cameras, or which transfer the image via this MQTT and Modbus protocols. And we have edge gateway, which is used to translate that protocol into the MQTT as a message format. And we have the Mosquito broker, which as described, it is a lightweight broker for sensing different kind of ingestions images. So it ingestion data. So it is very expert at ingestion of the data. And NetJetStream platform is a durable, high throughput event streaming platform, and it also ensures the data persistence, which is a very key term for our resilience part. It plays a crucial role into the resilience part. And for the serverless and the control category, we have the OpenFast function, which is the event-driven function to trigger AI inference and actions. We have the PLC actuators, which are the normal IoT industry or the manufacturing industry's control systems. And this is the system which we call the hystric, which is a circuit breaker. This thing we used for to avoid the loss, to avoid the cascading loss of other components. So it is just like a normal fuse or a circuit breaker in our house, that if the power outage occurs, so the fuse keep the circuit open to avoid damaging the other parts of the electric appliances. So the same concept, Hitris, is applied in this system to isolate the failing services. So like if one service is not responding, so this Hitrix circuit open this circuit by isolate those services, so further services do not get affected with the failed one. And it is just not we are assuming it is resilient. We are actually using the Litmos, which is a chaos engineering tool for resilience testing. Like we deliberately provide certain chaos scenarios, like we deliberately failed the node or isolate the network. So if our network is not connected, then how our system will respond. So this component is used for that part. And at the AI and the ML, we are using the AI inference pod, which is the TensorFlow Lite version of the model for low latency telegraph, as I described previously, with the collecting matrices in FluxDB time series database and Grafana for the local dashboard. MLflow is a platform for the model registration, versioning, and deployment. It keeps track of the model versioning, and PySwift, which is a secure federated learning aggregator. So it is a Python secure framework for securely aggregate the data. And for the long-term storage, we are using the cloud storage on the global cloud. And this is also the detailed architecture diagram. I will get it little zoom in. Here, the story is the same here. I just use the two clusters, so we can consider that this is the cluster at the Lahore, and this is cluster at the other city, let's say Karachi, or we can also consider it to be the different region of the factory. So here, I just want to show this. This cluster is isolated from, these clusters are isolated from each other, but are connected to this cloud. So here I will show the resilience scenario. Like if, for example, this cluster is locally training on its own data and performing all the actions, and only the Admiral is collecting the data at the cloud. And same for the cluster 2, which is performing all of its operation locally. As I described previously, these are all the same operation. So let's consider a scenario that what if the connection to this cloud gets dropped? Like for certain reason, if the cloud is down, then how our system will respond? So since our system is resilient, then it will not get affected by the cloud or the internet uh, disconnection. So if the internet is disconnected, then our system will work resiliently, autonomously without any issue. The my QTT data will trigger the Nets Jetstream platform, and before it will perform all the AI operations like the ML, PySwift learning, the TensorFlow inference. And as I described, each component functions like the Longhorn for the replicated storage. So all of the things will work autonomously without the internet. And for the same thing, for the same cluster, it will also perform all of its action without any issue. So now the main point to consider here is that this cluster is disconnected from the cloud, but it is performing all of its operations on locally, which shows the resilience. And once our cloud gets back connected, then here the Admiral agent plays the crucial part. So what it does, this Admiral agent from the cloud discover this cluster. And since this model is trained on the new latest data, so it will fetch those model updates from this cluster. And by updates, I means that only the model weightages, which are updated with the model training, not the actual raw data, only the model updates and the AI inference results. So like the TensorFlow model results, like whether the data is correct or not. So only those results will be fetched by this Admiral agent, and it will be used to train the global model. And once this model is trained, it will be redeployed to both the clusters. So in this way, it shows the resilience and also the federated learning, like it is learning from these clusters data without using the uh, manufacturing manufacturing data. Like it is maintaining the privacy, but it increases the accuracy of the current model, and it is redeploying the model to the each cluster. So in this way, we are continuously updating our model in autonomous way. Now, these are the scenarios like our system is resilient and fault tolerant at the edge. So it is designed in such a way that it will stay operational even at the nodes or the links of services fails. This is the scenario that I described previously. Like, for example, if one of our node, like the AI inference pod, gets failed for some reason, then our system will not get affected, but the Kubernetes will automatically detect this failed node and it will reschedule it to the healthiest node. And once it is scheduled, since we have the longhorn replicas of the data at the other node, so the healthy node will refer to that longhorn storage for the data. So it by using this technique, the data is not lost and our system is working uh, seamlessly. So the component which are responsible for this task are the Kubernetes self-healing, because it automatically reschedule workload on the healthiest node as I described, and the Longhorn replication. These components keep multiple volumes of the data across different nodes, and also the Jetstream. This Jetstream platform also guarantees the message delivery by storing the streams of data internally. It also stores the data at the Longhorn storage, but internally it also possesses to store the uh, stream data. And this historic circuit breaker, which we use to isolate the failed services to prevent the further cascading failed effect to other components. So in that way, our system does not affect from one of the node failure or any kind of incident. And it also ensures the local autonomy, since our AI inference and our local decision making is running automatically without any issues. And this lit chaos is we use to simulate the fault. So as we are saying that to fail the node or port kill or network loss, what kind of uh, uh, any error issue. So another thing is the federated learning and the model life cycle. So this thing implies that learning continuously at the edge without sending raw data to the cloud. So this is the same thing I described previously, like our all of our models trained locally on local data. And once they are trained, only the results like the model weightages and these kind of things are aggregated at the cloud. So this ensures that the private data of the company doesn't leave the company premises, and only the results are sent to the cloud, and which are used for the aggregated for the combined cloud global model learning, and it is redeployed across different clusters. So in this way, we are continuously updating and optimizing our model without using the public data. And the third is the multi-cluster federation, which is the part of the Admiral. As I already discussed this thing, that each edge site has a local Admiral agent. So this Admiral agent ensures that it gathers data from all of the edge sites and combine it into the cloud for the global model training and global operations. These are its component, like it is used for the service discovery, to discover all the cluster, for the configuration any kind of deployments or the secrets consistent across the site, like Kubernetes secrets for the deployment or configuration. It syncs across different cluster, and also each site continues running autonomously during outage. At this point means that each site is running independently and can perform their own inference on their own. And finally, it performed the global updates for connectivity and restore. So this marks the end of the presentation. If I, for the conclusion in future, I will say that we have deployed this, by deploying this resilient edge infrastructure, we ensure that our system is running autonomously, ensure resilience and low delay. It also preserves the privacy of the data via the federation learning and the secure collaborative model improvement. And it also guarantee the reliability by using the fault tolerant and self-handling capabilities, chaos engineering practices. So this is the conclusion of my presentation. And for the there is also the space for the always space for the improvements or the future roadmap. it could be enhanced with more advanced vision models to detect the minor level details of the image. Like right now, this is just using for the weld detection, the quality of the weld, but we can enhance it to check more microscopic defect system, like more micro level things. And also for the peak production efficiency, we can introduce certain scheduling policies or intelligence, so that in that case, critical processes which are very for the processing are very critical, keep always running in the peak hours. So these are the things that could be enhanced into the future working of this presentation. This marks the end of my presentation.
Okay, just in
Thank you
time.
so much.
Just in time. Okay, you can close the sharing, please.
Okay.
So how long have you been working at Huawei?
It's about 3 years.
How's the experience so far?
Experience so far is very good. I am working here right as a Python automation engineer. So basically, since it's a very huge organization, so we are automating the business processes for the efficiency and cost reduction.
Okay, how big is the operation of Huawei in Pakistan?
Actually, it's not officially the Pakistan center. Like they have the region, so we are affiliated with the Egypt JC region. Like we are working with the Egypt JC. They are
Okay,
providing services for the Saudi, UAE, the Mika region, and all the South Africa. Different kind of services, which I cannot disclose here, but
I understand. I
operation.
understand. Okay, so it's a huge company. I mean, the revenue goes in almost 120 to 200 billion
Yes,
dollars, right?
because they have different business scenario. They have invested in different kind of business.
Mm. So are you guys in the telco side, or are you guys in the automation of the business processes side?
Not specifically the telco side, but we support those person who work right on the field of the telco side.
Okay. Okay. All right. Okay. Bismillah. So you've been working as an automation engineer. I saw that on your resume, right? So primarily, let me open that quickly. So primarily your stack is Python.
Yes.
Okay. Okay. Bismillah. All right. So let's start the test. Bismillah ar-Rahman ar-Rahim. So what is the primarily, if I have to mention, okay. All right. So what is the primary operational reason for shifting AI workloads from cloud to the edge? You mentioned something which was very interesting. Bring AI to the data, not data to the AI. Can you explain that, please?
Yes, because the primary reason for this is because I'm targeting actually the IoT industry, or the for industry 4.0, which is the future of every industry, where the massive amount of data is generated, and we need huge operations with low latency. So our key terms is the low latency, that we need decisions, but at very quickly. And our traditional cloud AI lack this capability, because it cannot, because there is always the lag, because the sensor send data to the cloud for processing, and then it come back. So this life cycle takes time. So to address this, I introduced this edge AI, which is why we move the processing device directly to the sensor which is generating the data. So in this way, it reduces the latency and also enables the autonomous AI based decision.
Okay. When you have to answer the question, you have been working in the industry for quite some time. You can start like this. The primarily operational reason is to eliminate cloud induced latency. You mentioned latency, but you have to mention it like in a much more eloquent manner, cloud induced latency, and ensure real-time decision making. Manufacturing lines cannot tolerate delay, because even milliseconds of latency in detection or control loops can result in production stoppages, right? Or defects. By
Also,
processing locally at the edge, if you bring AI closer to the, over there, like you mentioned, bring AI to the data, right? Not data to the AI. So if you bring AI to the data, the inference happens at microseconds to millisecond speed without dependency on internet connectivity, right? So you got the score, but I'm just saying, when you go and you met and I saw your resume, it says Europass. What does Europass means? What does that mean?
So actually, I designed this CV as per the Europass format, which is the CV format used across Europe.
Okay, in the European format. Okay,
So
okay.
European format, so that's right.
So even for the European companies, right? Uh, you will see that this is exactly what they're doing right now, right? In terms of implementing AI into an automation into their business processes. That's where the next development is happening right now in the industry. Um, I believe Huawei might be at the forefront because normally they take the first step, the first go-to-market advantage in terms of doing things, right? So they might already be doing all of these things. You might already be experiencing these things happening in some capacity or the other, depending on which group you are working in right now, right? So your answers needs to bring in some
More
business,
detail.
I would say the business jargons, right? Which attracts basically the employers. On the page 3 of the presentation, why is bandwidth saturation a critical issue for factory deployment? Why is that?
Page 3, bandwidth heavy. I'm this bandwidth heavy. It means that in the traditional cloud, all of the data, like all the video streaming data, the images data, is transferred to the cloud for processing. So I could say that even if the raw data is sent to the cloud, which is not good for the cloud, and it also wastes the cloud resources because raw data is being sent to the cloud.
So for the ETL purposes, in your diagram, what do you intend to use? I mean, what are you proposing to use in the ETL? From the ETL means extract, transform, and load, right?
Transform load.
Yes. So what kind of data pipelines are you establishing? What kind of solution are you using?
You mean that like how the system is fetched into my architecture and how it is processed? This kind of
Yes, I
architecture?
mean, when you bring in all of this data, right? And you mention bandwidth heavy, it's mentioned here, constantly sending raw sensor video streaming data overloads
Yes.
networks. That's the bandwidth heavy. There's a lot of video data, right? So how would you create an ETL pipeline for this where AI is sitting there and is able to analyze the data almost in real time? How are you addressing this challenge?
This challenge, for the data part, I'm addressing it like it. We need to process all the data locally. So, like instead of moving all data to the cloud and processing, what we introduced the IoT Edge AI technology, which is directly placed right at the edge where the data is being generated. So if the sensor is or the camera is generating the data, so it is processed locally, and all of the components that are required for the processing, like actually it is our Kubernetes light component is based on the Jetson Nano processor. So we place that processor at the edge of the device for local processing, and once it perform all the operations like analyzing the data, and all of the things are performed locally, and only the results, like whether the image is up to the mark or not, only that is sent to the cloud. So this is my approach for this. And as for the ATL part, I will say that this is like our data is loaded into our system via the uh, sensors, via the Nets Jetstream platform, which is our reliable platform. Like it also ensures the data persistence.
No, I mean, so let me show you, right? This is our own system, right? I just want to see how are you addressing this challenge. So this is the system that we have, right? Uh, on a daily basis, we have 23 sources, right? The data retention time is 5 years. What are you using? Like, for example, these are the data sources. And in our case, our data sources are different. In your case, this is the IoT devices, right?
IoT devices.
So how is the data going? Like, what is the ETL engine? Where are you storing? How is the AI sitting there? Like,
Okay.
that's what I would like to know.
Okay, so my data flows like from sensor. It is feed into the mosquito broker, which is a lightweight ingestion. And that mosquito broker, it's publishing this data to the Nats Jetstream platform. We are using this Nats Jetstream platform for durable event or messaging streaming. And now we have feed the data into our system. Next part is processing that data. So for the
Okay.
processing part, in our pipeline, we have used the OpenFast, which is an open source serverless computing platform, which works on the event-based code execution. So like only it will trigger the code when the data will arrive in our system. So this OpenFast will be used for the processing, and this processing further involves the AI-based processing from the pods, as I mentioned in the previous slide, the TensorFlow pods. And all after the processing, we need to take the counter action, which in our case is either stop the conveyor belt or either isolate the defected part. So this thing OpenPass is triggering the command via the MQTT uh, to the PLCs or the actuators to perform the counter action. So if
So,
I
for the services at the edge for the IoT, are you using MQTT, or what's the difference between MQTT and NATs?
Okay, so both of these things are message ingestion platform, but I have placed both of them due to one certain specialty. The MQTT this MQTT is just a messaging for protocol format. I would say main thing is the Mosquito. Like Mosquito, it's between the Mosquito and the Nats Jetstream. So this Mosquito platform we have used because it is the very native listener of the sensors data. Like it is very much used in the IoT industry. It can sense low bandwidth event messages very frequently. So it is very good at listening. And I would say it's a very specialist for the listening part. So that's why I have used the MQT Mosquito. And for the Nets Jetstream, I use this because it is also ingestion component, but it possesses one specialty. Like it didn't just ingest the data, but it also persists the data along with it in internal components. Like it store it as a stream of bits
So
internally.
let me
So
ask
it also
you.
includes the backup.
So I understand MQTT is lightweight. Uh, Mosquito is designed differently. For an unreliable networks, would we use MQTT or would we use NATs? What would we use?
In our case, since it also possesses the unreliable networks, we will use the both because these both complement each other. One is very good at listening the data, and the other is good with the event streaming and also ensuring the persistence. Because only storing the message, only ingestion of data is not important in our system. It also need to keep some buffer of it.
Good job. Okay. All right. So let's jump in and take a step further. So, like Huawei, they develop cars, right? They are developing some of the best cars out there. I really like their cars, but they are expensive, but not as expensive as the other ones, right? So there's a robotic, I would say, there's a robotic welding station that is assembling the car. It stops abruptly due to false positive anomaly detected by the edge inference engine. Using your architecture,
Hmm.
how would you identify the exact chain of components that should be analyzed to isolate the root cause without relying on cloud connectivity? Because you talk about everything, you mentioned bring AI to the data, right? How would you do that? Give me steps. Step 1, step 2, step 3, step 4, step 5.
Uh, uh, so your question is like if the robot arm gets stuck, like it detects certain anomaly, then what step it will take?
Let me show you.
Please can you rephrase?
Hold on. Robotic. So let me show you because showing might give you a good understanding, you know. Okay. So this is what happens, right? In a robotic manufacturing.
Right.
See what they're doing? So the robot is working and it is trying to assemble the car, right? Right? And
Right.
it's working. So my question was, right? There's a robotic welding station. This is the station, right? It's working.
Yes. Yes.
And it stops abruptly. It just stops due to false positive anomaly detected by the edge inference engine. Because you have this AI inference engine working at the edge, right? That's what you mentioned. Bring AI to the data. That was the first line I pick up when you were presenting your presentation.
Right.
That's how I started building up the questions, right? So using the architecture that you have, the robot was working. Immediately it stopped, said, I can't do anything. Something happened, right? Yeah, and it stopped. It said like, I need to check when, and it detected some anomaly, the inference engine. So the robot stopped. Using the architecture that you have, how would you identify the exact chain of components that should be analyzed to isolate the root cause? I mean, without relying on the cloud connectivity, you can't connect on the cloud. It's going to take time. That's where the nets is running, right? The jet stream and all of those things.
Right.
You just want to make sure, like, they send you, they say, Muhammad, go on the floor, quickly resolve this issue. We can't stop the manufacturing. The robot needs to keep on welding. We are chop chop, we are on schedule. We have to be on schedule. How would you perform the root cause analysis to identify the problem and then continue the work? How would you do that?
So my answer would be in the two parts. So like I have used the
So
Grafana local
explain to me,
database.
the investigative chain of command. Let me give you. This is
Yes,
all coming from your network diagram, right?
I got your
The
question, but
first thing,
yes,
the
please.
first thing will start. Let me help you. The first thing will start from how do the robots work when they work? What are they picking up? How do they pick the
They
data?
take the image data. The camera is detected and camera is attached
Sensors,
and
sensors. So
sensors.
the
Yes.
sensor validates raw, OPC, Modbus, feed, whatever they're getting, right? So the sensor. So step one, sensor. Step two, what do? You look into?
Mosquito or the Nets jet stream,
Yes.
which is
Mosquito broker, MQTT broker injection logs, and the mosquito. Step three, what would you do?
so step three is I will check the next component, which is our open fast platform, which is actually executing the inference.
The jet stream
And
replay to confirm whether the anomaly event was persisted, where is it coming from, stuff like that, right? Step four, what would you do?
step four is like checking the local because after the AI inference decision, the matrices are collected into the influx database. So and which is
So you
further
look
connected
into open
on the
fast
dashboard.
inference function logs for model execution race, right? Step
Those
five,
function logs will also be stored in the influx database.
yes. And then step five, you know, where would you look
Step
into?
five Step five is since it is connected to the dashboard. Other part is the dashboard and the actual our counter action.
The Longhorn volumes for
Which we are
inference data snapshot, step six, and then step. So this is the kinds of questions you will face when you go for the interviews, right? I believe you will be ready, inshallah, but you just have to understand.
I just have one confusion, like as you mentioned that if the robots stop working, so whether you are referring to the hardware part or the orchestration software part.
No, I mean
Because
it's the robot was welding and it just stopped. It's the
so
hardware part.
it gets me confused, because if the hardware part is down, so definitely our operator will go to check this thing. But for the software or the working, so this system is resilient, then how it will fail? And what
When I'm saying, the system welding station stopped abruptly due to false positive anomaly detected by the edge inference engine. The edge engine, this is the software part. The edge engine is sitting there collecting and reviewing the data, right? And it detected some anomaly and it stopped. It was a false positive. It can be any anomaly. It can be a bend or depression on the steel. Because when it is welding, it is checking at the same time, is it the right bend? Is it the wrong bend? Right? Is it the perfectly aligned or not? Right? That's how you train the models, right? So that's what I was asking you. It's not a hardware issue, it's a software issue because the inference in what is the inference engine doing? It's continuously at the edge reviewing the logs, right? So that's what it is doing. So that's what I wanted to know. These are the kinds of questions you'll be seeing, and we have the projects. Are you doing a Razak?
yes, I have done the part initially, like the Python, like the Linux and the Docker lab, but I do have 2 months, so I need to perform other
You
labs.
have to do the labs. The labs are where you will see the projects. I've placed projects like these in there,
Because
right?
right now I do studied the tools and theory, but I lack the confidence because I haven't performed all the practical labs. So,
You have to perform the labs, because we will discontinue these live interviews. Everything will now be on the labs. So you do the labs and the MCQs, and then do the labs. The labs will be five kinds of labs. The ones you're seeing right now are the basic and intermediate labs. If you do them consistently, the advanced lab will open, and you will have 24 hours to do the advanced labs. If you do them on time, you get the score. If you continuously do all the labs on a daily basis, 3 hours, then after advanced lab, we will in the next few days, you won't know when the labs are opening, but once they open, you will get a alert saying you have 24 hours to complete the challenge lab. And then after the challenge lab, if you continuously keep on doing all of those and you pass, then the expert lab comes in. If you complete all the labs for a given course, you score full points. That's how we have designed the new system, right? So you have to do the labs. You will have 24 hours to do the labs, right? Gradually, the system will ask you, open your camera because I need to see you if you are Rowaim Safdar or you're someone else, right? So it will take a screenshot of your face and it will say, okay, you have 24 hours to do the labs. Go and do the labs, right? Complete the lab. Okay. The next question I have is, in your architecture, considering the multi-cluster architecture that you propose, you know,
yes.
propose a scenario where the CRDTs would be essential, even though the presentation did not explicitly include them. Explain how missing CRDT logic would cause inconsistent uh, decisions across sites. You had two sites, right? I mean, how would you do that?
CRDTs. I forgot the abbreviation. It is conflict resolution data type. So
Yes. Yes.
for the scenario,
So the scenario is
scenario is like I will create.
propose a scenario where the CRDTs would be essential. They are required, even though in your presentation you didn't mention them explicitly, include them. You know,
So
how would be uh, the actuators, like they are taking they're making they are assisting you in the decision making, right, across the sites. So if the CRDT logic is missing, would that cause inconsistent decision across the sites or not, and why?
we can consider the scenario like the federation learning for this thing. Like since cluster one is training their own local data internally, I would assume that it is not connected to the cloud. and the cluster 2 is internally training their own model. But since we mentioned that when the cloud is up, then the cloud admiral will aggregate the updated data from both the clusters. And that data could be the model weightages, like the tuned model images and the inference result and these kind of data or logs or matrices. So here the CRDT technique is implemented because this data could be inconsistent. Like since the both clusters are independent of each other, I would simply say numbers. Like for example, the number 3 is coming, or number 4 is coming from the cluster 1, and number 5 is coming from the cluster 2.
Let me ask
So
you a question. The CRDT strategy can lead to a divergent values, right?
yes, it combine the both data, but without
What do
causing
you
any
call
conflict.
that? What do you call that scenario where their divergent values can be created?
The specific term, conflict,
Last
conflict of.
right wins. Last right wins, right? So that's what you call the divergent last right wins. The LWW, as we call it, right?
Okay, so
Right?
the data that arrives later
Yes.
has the more
This can
priority.
lead, so yes. So because values, it discards concurrent updates rather than merging them, right? That's what it does. Um, well, that was like a very tough question. Let me take a step back and give you the federated learning question that you just mentioned. So you said federated learning, right? So let me give you something like that. So in a cloud outage lasting 96 hours, describe how the federated learning architecture would degrade and how the system could still execute safe autonomous learning cycles without global aggregation. You mentioned all these softwares in your resume, PySoft, MLflow, all of these things, right? Longhorn, which is part of this thing. How would you do this thing using all of these different pieces of software?
So as per your question, like I would say that there is no cloud in our this scenario, so only the local inference. So it will work in the seamless way because the main part of the system is like performing or daily or normal operations seamlessly without the cloud. So it will sense the data from sensor to the Mosquito component, which is running internally at the edge level, and this Mosquito will uh, fed the data into the Nets JetStream platform, and all the same cycle will be executed, like the data inference and data decisions and local data storage. Since
No,
we
no, no,
have
no.
all,
So in this case, there's a prolonged outage, right? Uh,
we
how would
we will.
how would the autonomous learning cycles will keep on executing without global aggregation? There is no, I mean, autonomous cycles are, like what would the local based training, would it continue normally? Like the local PySoft based,
Yes,
you know?
it will local PySoft component will also be present at the edge site, not just the
Okay,
cloud, and it
okay,
will run the previous model version. Like
okay.
it
And
will do
how
up the
would the
previous.
ML flow work? Okay, that's fine. That's good. How would the ML flow then? How would, will it be able to, the model, can it push updates to the ML flow or not?
So technically, I introduced the ML flow just for the cloud part because it is just used for the versioning.
So
So
it cannot, right? So it cannot because
because
that's the different
cannot
thing.
because it clouds
Yes.
is not there,
Cloud
so
is
it will
down.
run
Right.
on the
Good,
previous.
good. So what happens at the edge nodes? Can
It will
they,
only rely on the previous version of the model, like the
mashallah,
previous
good.
version.
Nodes, edge nodes maintains local versioning histories using Longhorn volumes. Good, mashallah. What happens to the inference? Will it be able to detect any discrepancies between two sites? What do you call that?
Um, two side, you mean two clusters?
Well, there are two sites. Uh, you know, cloud is gone, 96-hour long outage is done, but they still have to work, right? So
Yes.
inference accuracy will be there or not between the two sites?
Not between the site, but because each site is running their own system.
Yes. So
But
inference accuracy may drift differently across sites, right?
yes,
Because
it will definitely it will diff because there is no central admiral configuration between those.
good, good. And the last part is going to be the global aggregation. What happens with the global aggregation?
So as far as our cloud is not there, so the global aggregation thing will be affected. But
Yes.
if it gets connected, then Admiral, this is actually the Admiral agent function. So it will discover both clusters and aggregate the data from both the cluster for aggregate
So
for
without
the
global, good, mashallah. So without global aggregation, clusters rely on locally,
previous model version,
yes,
local
accuracy
storage
matrix,
of that.
and can deploy locally improved models through OpenFaaS or global through
Yes,
global
those
consistency,
components
and so that's
that
what they do.
can
This
get
is
data
very
from.
important, right? That's I did a project long ago for an autonomous. There was a This project was for basically a company which was a Japanese company, and they were uh, essentially had these huge robot armies, right? Which were packaging, which were moving things, within the warehouse, right? So preparing the orders, right?
Right.
And if the cloud is not there, then what happens, right? So each of these different sites were connected with these. There was a cluster, local cluster, but then also all of these sites were also connected to the cloud, so that they can see warehouse number one is packaging, all the delivery for XYZ vendor, which is closer over here. Warehouse number two is doing this. Warehouse number three is doing this, right? And they were trying, but if there is an outage of the cloud, and it happened, right? They used to do and test their BCP and DRP, business continuity planning and disaster recovery planning. If there's an outage, we still have to continue doing our business. We still have to deliver the goods, and we still have to make sure that the robots keep on working, right? So that's where all of these things comes in. Okay, so you are an AI ops engineer, right? You're about to pass, inshallah. So you're an AI ops engineer. The jet stream retention has filled up to two clusters edge nodes during a high volume
E-cars.
defect detection shift, right? Explain how your architecture prevents data loss and what corrective actions should be automated to avoid production interruption.
So to address this thing, so I would say the two components plays the important role to ensure the data is not lost and it is there, even if some incident occur. So the Nets Jetstream platform has the ability to store a stream of data for a very limited time or a limited kind of data. But it also replicates that data to the longhorn storage, which is our actual component. So this longhorn storage is responsible for storing that data across the multiple node. So let's say if one of our node goes down, like any a inference node of the itself nets jetstream nodes down. So we have the replica of the data storage across other nodes, which longhorn storage store as a block storage. So let's say our AI inference pod is down, but we have the replica of the data across the other nodes because in the parallel longhorn perform these tasks by replicating the data. So when the new pod is scheduled on the healthier node, so it refer to the that replicated data and it can perform the actions with the same data without losing the data. So in this way, we ensure the data is stored.
All right, so we are at the last leg of the question. So you have this K3s, right? Control panel, right? So if the K3, you know, so if the K3 plan mode in an edge side goes down during a synchronized federated model rollout, right? Explain how the system behaves. Who wins, and whether inference pipelines continue without corruption or not.
You will mention which one node?
It's a
Which node for?
synchronized model rollout, right? So you are pushing, so the control plane node is working in the K3, right? So the control plane node is there, and it goes on the edge side, it goes down during a synchronized model rollout. So you are pushing out the rollout updates. Something
Mhm.
happens to the node went down. Explain how the system will behave now. I mean, there is no control plane mode. Node is not there. The node is gone. Who wins, and whether the inference pipelines will continue without corruption. What happens to the existing loads? What happens to the inference pods? What happens to all of these things? What's the behavior? How would you see all of these things?
So there is a thing in the Kubernetes, we called it the deployments. So this system ensures that like we give it the state of the nodes. Like, so there is always not the one control node, but we will have a replica of that node, because we cannot rely only on the one control node for the inference. If that nodes
Listen to the
go.
question carefully. This is the last question, right? If the control plane node fails, explain how the system behaves and who wins, whether the inference pipelines continue without corruption or not. What happens? Is the local system winning, or over the federation inference pipelines, or who wins? I mean, I'm giving you, if I speak too much,
Federation
the whole
pipeline
answer will go out, right?
Federation pipeline will wins, because the control node is actually the brain of our system. So if it goes down,
If the control node goes down, the local autonomy wins over federation inference pipelines. Remember this. The cluster prioritizes operational safety, right? Remember, the operational safety is also very important. All the operational controls are there. If the control node goes down, it will go back into a bypass mode and say all the operational things, safety purposes, and all of those things, I have to keep on continue working, because the federated, you know, how are they connected with each other? Both the sites. What do you call that layer?
Admiral Federation.
The federation, right? The federation. If the federation is down, what happens? Do they both stop working? No, they continue working, right?
No, they continue locally.
Locally. So the local autonomy always wins. The local autonomy wins. Just like in the provinces, right? And this will happen. I saw that you are a Pashtun, mashallah, right? So from Kohat. So I have some of my uh, bhabis, my you know
I
my
wonder
sisters
how.
who are from Kohat as well, right? So if anything happens with the federation, the local Pashtun will always fight and try to keep their autonomy, right? Dr. Sar Ahmed told this long ago that this will happen. And when that happens, you know, so forget about all the NWFP. It will go out, right? The Northwest Frontier Province will go towards their brothers who are on the west side, right? Not on the east side, but on the west side. East side is the Pakistan mortal enemy. On the west side are the brothers, right? So this will happen. So when the federation fails,
Yes,
the
now I
local
got it.
autonomy wins. Remember this: when the federation, when the federated layer fails, the local
Local
autonomy,
autonomy.
the local autonomy wins. And the second question, the part is whether inference pipelines continue without corruption or not.
Yes, it will continue, because locally we have the PyShift agent, and which will internally train the model, but it will not receive any further updates, because our global system is
Good,
not.
mashallah. So they will continue uncorrupted because model updates are atomic and version, right? Right. So
It's my bad. I mistook the question. So I thought you were referring to the edge side, like my Kubernetes control plane, the master node failed. So I was answering with respect to that.
Well,
I
I
missed.
was saying the same thing. If the K3 control node is in on the edge side goes down during a synchronized or federated model rollout, you were pushing something, everything. So the K3 model control node is gone. When that node is gone, because that,
Federation.
the federation is dead, right? The federation is dead. The federation is about to go down. I mean, Pakistan always comes closer to destruction than someone's make dua and Allah saves it. Then it goes closer to destruction. Then someone makes dua, then Allah saves it again, right? So this things keeps on happening, right? It's ajib, like, so, but it's the weakness of us as a nation, as a Muslim ummah, that we are divided into different things. But anyway, good job, mashallah. Okay. Right. How was your exam?
It was good.
Okay, Bismillah ar-Rahman ar-Rahim. So, mashallah, you secured, let me double check. Hold on. 4 and 6, 5, 11. Good. And 3 plus 1, 5, 4, 9. Okay. All right. Bismillah. So you secured, again, I have to put this on the system. Some notes are there, some notes are still here. So I have to copy it. That takes me another 30 minutes to do that once we are done over here. In the presentation, you secured 21 out of 25. It was good. It was not hypothetical. It was a plan that you presented, right? You didn't copy pasted the stuff from here and there, right? Uh, that's what we want to see, originality and stuff like that, right? I'm guessing, like, have you seen or experienced this kind of automation in your company or not?
No, not this kind of automation, but while
Closer.
preparing the presentation, I developed interest in trying this, but I cannot do it at the company, so I will do it personally.
Yes. We are providing you the lab environment, an excellent lab environment that covers all the things. So in the presentation, you secured 21 out of 25, which is 84%. In the Q&A, you secured 20 out of 25, which is 80%. So altogether, you secured 82% is your final score. You have passed your exam. Okay? MashaAllah. So when did you started the journey with Nafi? And I saw that you did your degree, right?
Yeah.
What do you want to do? Where do you want to go? What are your aims? I understand कि तुम यहाँ काम कर रहे हो. It's okay, right?
No, not right now.
Okay. So what do you want to do?
So basically, my journey with the Nafi started like 2022. Previously, I was studying CAD from this, but unfortunately, I didn't completed it. I just get to know about the Python, the Linux, and these foundational things. And
From the CAT.
I got from CAD, yes. And I got introduced to the Nafi platform by one of our teacher, which I discussed with you as well, Muhammad Zohaib Afridi. He's from Kohart. He has also worked with Al Nafi as a cybersecurity professional. So he introduced me to the Al Nafi platform.
Muhammad Zoeb Afridi working for us. I can't remember. There are so many Afridis. I'm an Afridi myself. So many Afridis, right? So I don't know. Okay. Anyway.
But and previous year later, I started the AI Ops diploma with Al Nafi. So where I studied the different technology, like I got everything I saw for the first time. Like before, just except the coding, everything was new to me. Like the DevOps technology, the system operations, like the automation, these kind of everything I was introduced first through the Nafi platform.
Okay, so did that help you in terms of getting where you are right now and being successful?
Uh, Not directly, because here at Huawei we are doing the automations, but not the DevOps kind of automation. But we are only just more to the robotics or process automation side, like software bots, building the
RPA.
software
Okay.
RPAs.
RPS.
So
There's a separate track for RPA, right? Which we have covered. If I have to, before coming over here, we call it the robotics and automation, right? In that track, we have covered, if I have to go through all of those things. In that track, we have covered edge AI and IoT integration, cloud edge continuum for robotics control, MQTT ROS 2, robotic operating system, and containerized deployment. The ISO 10218 standard, the IEC 61508, and safety certification for robotic safety and ethics. There are labs based on ROS2, Gazebo, OpenCV, TensorFlow, Prometheus, Grafana, Ansible, UI, Path Community, OpenRPA. There's a lot of things, right? And then we are giving you deep insights. I'm looking at the new, uh, basically pathway. We are then giving you, this is the new specialization with AI ops. It comes with AI ops, or once you complete AI ops, you can also go deeper into that as well. There's manufacturing and industry 4.0, healthcare robotics, defense and aerospace robotics, agri-tech robotics, smart cities and logistics, cloud and AI ops, right? It covers all the key things. If I have to go into detail, all the key jobs, if I have to look into that, that also covers the foundation of robotics and automation, complete different lectures, programming for robotics, which Pythons for robotics, C and C++, the ROS and ROS 2. Do you work on ROS 2? ROS 1 and ROS 2?
we only just work with the Python
Okay,
and more
that's
JavaScript.
the operating robot operating system, right? Writing ROS nodes, publishers, subscribers. It's a complete different world, right? So I'm looking into all of that. Uh, there is also embedded design using Arduino, Raspberry Pi, NVIDIA Jetson Nano. So we have some of the labs available through NVIDIA Jetson Nano and stuff like that. There are communication protocols, Modbus. There was something
OPC.
for Modbus in here, right? UART, I2C, SPI, all of these labs are there. All of the lectures are there on the new portal. So now we deployed a new digital rights management DRM system so that no one can copy and paste our stuff and download it and illegally sell it and stuff like that, right? So have you worked with LiDAR? Again, I mean, your job is more towards business
Software
process
automation,
automation,
business process automation.
right?
Yes.
Yes. This is purely sensor fusion, IMU, LiDAR, GPS, ultrasonic, vision sensors, SLAMs, something I like, right? There's also industrial automation and stuff like that. If you want to go to Germany, which is something you've mentioned, and you are positioning yourself over there, then you need to complete AI Ops Al Razak program. I cannot stress enough on why it is important, right? That is sufficient for you to secure 55 to 60,000 euro job per annum. Okay, for you to go there. You can go there on a work visa, which is something they recently started, chance visa, right? Go there and apply directly for work. Or you can go there to study and then complete 1 year of study and then apply for work. If I were you, I would suggest you to apply for chance visa because you don't need to go to do a master's, right? The skills you have is enough. But before you go there, complete your Al Razak. So plan to go there and apply for chance visa in the next 6 months. I don't know what the processing time is right now, right? How long it takes you to get there, right? Does it take 3 months, 6 months, 9 months? I don't know. Whether you apply, then they call you for the interview. Is the interview conducted in Pakistan, outside Pakistan? I don't know, right? That's where you have
Sir, it
to.
is right at Islamabad embassy.
Islamabad, how long does it take?
Karachi and Islamabad.
How long does it take to get the visa? What's
For
the
the
visa
work,
processing
I
time?
don't know, but usually for the study visa, it about the 6 to 7 months, 5 to 6 months.
So I'm just checking. So it says around 4 weeks for Pakistani citizens. Chance visa, opportunity, as they
Okay.
call it,
No, I don't know about
opportunity
the
card,
chance
right?
carte, but I'm
Yes.
referring by study visa. It takes more time.
Study visa takes time, right? The chance carte, as they call it, the opportunity card is better. Unofficially, some applicants report waiting times of 1 year or more, likely due to high volume of application. The exact time depends on the specific German embassy or consulate handling the application. Again, this is just a ballpark figure. But before you go there, you don't have to do this thing, this new robotics specialization. But if that is where you want to go, then you should pursue this. But studying the AI ops and doing the Ar-Razak is more than enough for you to be able to secure job in Germany, inshallah. Okay, wherever you, France or wherever you want to go. Just know this, that you may have to learn the language,
Yes, that's the prayer.
right? So for Pashtun people, learning German is easier. We
Because
already have
first,
the thick accent, right? Right. So that's the Russian and the German languages are something that is easier for us, right? Anyway, so cybersecurity and robotics automation, there's cloud robotics and digital twins. Again, uh, this is where we teach you Siemens, Annex, Unity, MATLAB, Simulink, and all of those things. So it's a complete world out there. My recommendation to you is go and complete your Razak. Pass your
definitely.
Kubernetes exam. Even if you pass your Kubernetes, you will not be working in DevOps, but you'll be working in different areas where you want to work, right? And that will open more opportunities for you. The automation part, the scope of the growth is very limited because once you automate, there's not too many things to automate. What will you do next, right? So once the automation pipeline is over, what do you do next, right? But there's a complete world out there in terms of infusing AI into the automation. So once the
Automation.
pipeline is automated, then how do we look into the data by bringing data closer to AI? Uh, bringing AI to the data, not data to the AI, right? Unfortunately, I was doing the same thing. Something I learned today from you, mashallah. A person learns new things every day, right? I learned from you that we
Yes,
should bring
we-
AI closer to the data rather than data closer to the AI, right? So, like the idea, I'm going to ask these guys to see how we can do that because we bring all the data into an ETL and a ClickHouse and the Airflow and all of these things. And that's where the AI is sitting, right? It is sitting closer to the data, but the data needs to be consolidated. In our case, we don't have IoT. So yes, we don't, and which is creating an enormous amount of data. So we don't need that per se, but still it was a fascinating idea. Jazakallah khair for.
my interest is also this thing. Sorry to cut. My interest is based on mainly my interest is like the intelligent system, not towards the IoT robotics side, but combination of automation plus AI.
The combination of automation and AI comes in the robotic process automation because in the robotic process automation, you need to learn how to, once the data is automated, the pipelines are built up, then you need to put the AI layer on top, right? And that's where uh, the action happens, right? So there's a lot of things happening, but again, you need to learn through various things. If I have to tell you, the Ar-Razak has different things, right? The Ar-Razak that you have, it covers all the 23 domains, but then there is also, if you do the specialization, and that's where you want to go, there's robotic fundamentals and kinematics. There's embedded systems and firmware deployment. There's control systems and mechatronics. There's robotic operating system and middleware. These are the different domains of Razak. There is digital twin and simulation systems. There's human robot interaction, HRI, and UX design. There's cloud robotics and edge computing, autonomous systems and navigation, IoT sensor, edge AI, and real time decision system. This is where everything happens, real time analytics and decision making close to the robot, right? And the list goes on. There are more than, I would say, 51. So 23 domains are of a Razak are there, minus 51. There are 28 more domains, which covers everything that you need to know in order to work in any industry you like, on any scenario you like, where you want to make intelligent systems which can make decisions, right? In the grand scheme of things, they are called as AGIs, right? The advanced generalized, AI, but they're not there, but everyone is working towards making them at that level. Will that happen? It's anyone's guess, right? But it will be different pieces that we piece together to make a system like that, right? Organizations are already making something like that. We have done something like that, right? That's raised our value to $125 million. And we are towards, our valuation is now going towards $1 billion, inshallah, in the next 6 months. The goal is to go towards 5 billion in the next 2 years, inshallah. So we have developed something. I'm not going to tell you all the things that we are doing. It's outside the scope of this, but there are so many other things, right? If someone wants to know where can I start, you have to pick up one place, and that's where you should focus on and get your act together, right? My recommendation to you is, you already are, mashallah, working in Huawei. Explore opportunities in Huawei. The problem here is that Huawei is technically banned in all the European countries and North America because of US,
Main concern, yes, that's the main
right?
concern.
But because of the US hostility, more and more countries are now going towards China to open their doors and start talking. They realize US is the main bully, it's not China, right?
Right.
Chinese companies have one policy, we do our own business, you do your business. We don't want to interfere in your affairs. We don't want you to interfere in our affairs, right? Business is a business, and a cup of tea is cup of tea. This is what we should do. And this is what China follows, right? Great policy. That's why they are a superpower, but they haven't started any wars. The amount of people the American foreign policy has killed is more than all the people killed, like I would say, globally because of its policies, right? Hunger, war, famine, its aggressive attitude and behavior, like using dollar as a weapon to do whatever they want to do, right? So there's a ton of things that they're doing, right? So
Right.
all of these things, they matter, right? So my suggestion to you is follow that pathway, right?
Right.
More and
Sure.
more companies are going towards the Chinese companies. They have their own problems as well, right? No one is perfect, but there are good European companies where you can work, inshallah. Okay?
Sure.
Complete your Ar-Razak program, because if you complete that, that will take you to the next level, even within here. Within I would
Wow.
say within Huawei, yes, within Huawei, you can certainly go out and do many things, inshallah, right? Inshallah. So that's my recommendation for you. Do you have any questions?
No question from my side. Jazakallah.
Okay, Jazakallah khair for your time. May Allah give you more success. Ask your parents to make special dua for me. Do you intend to go to like outside on a student visa or on a work visa? What are your plans? Anything planned out or
Mainly
no?
mainly on the student visa, because I don't think so like securing job there would be that much easy.
So
It's my
just to give you
perspective.
some consolation, right? And just to give you some confidence, right? I'm going to show something to you. You can do that at home as well, right? So this is your resume, right? So let's copy your resume. And you can do that as well. Do the same thing, right? Just give me one. So I'm going to show you something. And you can do this, on your side whenever you like. So this is your resume. So all I did was I attached your resume, right? Hold on. So I attached your resume here. and I'm mentioning attach is my resume, right? Let me see if the resume is right or not. Just want to make sure. मैं देखना चाहूंगा कि resume तुम्हारा सही है नहीं है क्या है, because उसका नाम कुछ और है, यहाँ कुछ और आ रहा है. Just want to make sure. Rowaim Safdar, right? Okay, so I did attach your resume. I'm going to do something. मैं तुम्हें दिखाता हूँ. Let me show you. And what I'm going to do is I'm going to copy the Razak program that you're doing, right? So Razak program जो तुम कर रहे हो, I'm going to copy that. Hold on. Razak internal. So
लिनक्स और डॉकर स्किल्स मैंने किए हैं और आगे
हाँ,
मजीद
मैं
काम
तुम्हें
इसमें।
दिखा रहा हूँ. I'm just showing. मैं तुम्हें दिखा रहा हूँ कि ये तुम्हारा रजाक प्रोग्राम है, ठीक है ना, जो तुम कर रहे हो. इसमें रोबोटिक प्रोसेस ऑटोमेशन पहले ही है तुम्हारा, ठीक है ना. सो ये तुम्हारा रजाक प्रोग्राम है. सो अटैच इज माई रेज्यूमे एंड आई जस्ट कंप्लीटेड माई AI ops with 82 percentage, right? And I am on path to complete my Razak, right, program with the following domains. I also intend to pass Kubernetes and golden Kubernetes, right? Certs, which my intention is to go to Germany. Where do you want to go? Germany, France, कहाँ?
You suggested me to go to the US, but
यूएस में भी तुम जा सकते हो. अभी यूएस में हालात ऊपर नीचे हैं, बट दे विल
नहीं
गेट बेटर.
उसमें यूरोप में जर्मनी ऑप्शन अच्छा लगता है, सो आप अगर
जर्मनी अच्छा
सजेशन
है, जर्मन से अच्छा
सजेशन
है.
देते हैं और तो
तो
हम भी देख लेंगे, लेकिन ये वाला
इज टू गो टू जर्मनी. बड़ी इकोनॉमी है, ठीक है ना, तुम्हारे पास वहां पर अपॉर्चुनिटी ज्यादा है. जर्मनी, राइट? शुड आई गो on a chance carte? What do you call it? Like something chance visa, Germany, right? They call it something, right?
स्टार्ट है। लैंग्वेज थोड़े उनके मुश्किल है।
यार वो सीख जाओगे तुम, कोई मसला नहीं है. मतलब कि वो इंग्लिश में ही सारा काम होता है, हर चीज इंग्लिश में ही है. Chance carte visa is chance card, right? Something like that. So we'll say go on
सी
chance
एच ई एन
visa.
के आर इस तरह कुछ,
Sorry, क्या है? KAR?
कि हाँ वो इस तरह करके चांस कार्टे।
It's a CHANSKARTE, Germany. Right? So yes, so chance card is Germany, right? So जब जा रहे हो तो कुछ करके जाओगे ना उसमें, ठीक है ना. चांस कार्टे visa to hunt for a job, or should I go there to study MSc and then hunt for a job, right? Which option is better, right? देखो, मैंने कुछ नहीं किया. मैंने तुम्हारा वीज़ा लगाया, सब वो जो भी तुम्हारी चीज़ें सब लगाई हैं. एंड दिस इज, आई वांट टू सी कि वो क्या जवाब देता है, ठीक है ना. सैफ, दिस इज यू, राइट?
नहीं रोएम
नो,
सब तो शायद वो पुराना कोई वो रेफर कर रहा है, लेकिन वो
hold on. That's why I
परसेंटेज।
was kind of like, that's why I was kind of like skeptical कि resume वही है, किसका resume क्या है. Hold on. Let me see quickly Rowaim Safdar and go back, edit, and copy all of this, cancel, open a new window ताकि context खराब ना हो. And this is your resume. So Rowaim Safdar. Yes. ठीक है. के ऊपर तुम देखो कि तुम्हें क्या जवाब आता है. सुभान अल्लाह, अजीब. So I don't know why it is saying Saf.
ये स्क्रीन शेयर है आप?
I don't know कि क्यों वो सैफ कह रहा है, why is it saying that?
ये स्क्रीन शो नहीं हो रहा आपका?
I don't know क्या है, क्या मसला है, सबर, वेट।
शायद वो कोई पिछला कोई बफर कर रहा हो।
Yeah, I mean, just trying to see कि क्या मसला है, sometimes it happens, I mean,
एआई इतनी भी एडवांस नहीं है।
hallucinations, right? So,
Hallucination।
Bismillahirrahmanirrahim.
सीआरडीटीज लगानी चाहिए यहाँ पे।
It is still saying Saf. I don't know why it's saying Saf, right? For some reason, it is pronouncing your name incorrectly, right? So let's see. हम जाके देखते हैं उसको कि वो क्या कहता है. So वो कह रहा है कि फर्स्ट ऑफ बहुत अच्छी बात है, तुमने पास कर लिया, तुम्हारा सीवी देख रहा है, वावे ऑटोमेशन आर्किटेक्ट में तुम काम करो, सब ठीक है, जबरदस्त, बेहतरीन है. So let's break it down, right? So move to Germany. This route is faster, cheaper, and designed specially for skilled professionals like you with a strong tech stack and certification underway. मैंने तुमसे कहा ना ये करके जाना, ठीक है ना?
बिल्कुल एग्जैक्ट।
Immediate access to employers, DevOps, ये सब चीज़ें तुम्हें वहाँ मिल सकती हैं. No need to pay for a full MSc, ठीक है ना, इंटरनेशनल्स, क्योंकि उन्होंने भी ख़त्म कर दिया, अब फीस देनी पड़ेगी, राइट? कुछ इस तरह की नई लेजिस्लेशन आ रही हैं. Germany has a critical shortage, all of these people. Chance gives you 12 months to job hunt plus work part time. Your background maps one on one with Germany blue card shortage list. तुम shortage list में आते हो. Requires proactive networking and applying aggressively. Employment may take 2 to 4 months depending on region, Berlin, Munich, Frankfurt, and fastest. Probability of success high, 60 to 70% probability of securing job within 4 to 6 months. ठीक है ना? Based on your profile, stack, real world experience and Razak deliverables. Option 2, तुम जर्मनी पढ़ने के लिए जाते हो, तुम सब कुछ करते हो, सब कुछ अप्लाई करते हो, जाते हो, जो भी करते हो, ठीक है ना, वो करते हो, ठीक है ना. ये फास्ट है आरओआई, ये थोड़ी स्लो है क्योंकि तुम्हें पूरा काम करना पड़ेगा, राइट? सही है. तो मेरा मशवरा होगा, इफ़ यू आस्क मी, ठीक है ना, इफ़ यू आस्क मी, मैं तुमसे कहूँगा फोकस करो गोइंग टू जर्मनी. इफ यू वांट टू गो टू जर्मनी, ठीक है ना, ऑन अ चांस वीजा, यू कैन गो देयर इंशाल्लाह, बट कंप्लीट द रिक्वायरमेंट्स. अगर तुमने कर ली,
इंशाल्लाह मैं
देन यू कैन गो देयर,
किसी से
राइट?
कॉन्फिडेंस मिलेगा
दैट
उसके
इज
बेस पे बंदा।
समथिंग. हाँ, जब तुम क्यूबरनेटीज पास करोगे, गोल्डन क्यूबी एस्ट्रोनॉट बनोगे, क्यूबरनेटीज बन गया, गोल्डन क्यूबी क्यूबी एस्ट्रोनॉट बन गया, ठीक है ना, दैट विल इम्प्रूव योर कॉन्फिडेंस. इसी फील्ड में रहो, बहुत काम है, there's a ton of work to be done, right? You can go there. You can also go to Middle East. That is another opportunity for you, right? Middle East में इस वक्त ओमान के अंदर 2040 विजन पे वो काम कर रहे हैं. सऊदी के अंदर 2030 विजन है. यूएई में 2070 विजन है. They're all building up their visions because the petrol demand, the petrol, dollars are going down, right? World is going to different sources of energy. यूएस किसी से अब ले नहीं रहा, यूएस खुद निकाल रहा है, यूएस वेनेजुएला पे हमला करके कब्जा कर रहा है, यूएस ने अपनी पाइपलाइन बना दी है, राइट? सही है. सो या आई मीन नाउ दे आर इररेलेवेंट, दीज पीपल
पाइपलाइन।
आर इररेलेवेंट, इररेलेवेंट हो गया ना. तो सो नाउ सो एवरीवन इज, सो यूएस अंडरस्टूड कि यार डेवॉप्स पढ़ के उसको समझ आ गया कि पाइपलाइन कैसे बनानी है. सो नाउ दे डूइंग ऑल ऑफ दीज थिंग्स, राइट? सो तुम्हें ये देखना है कि वेयर कैन यू मूव स्ट्रेटेजिकली फास्टर. In the next 20 years, there will be extreme demand for all the peoples who have AI ops skills with certain specializations that you can choose. You don't need to pick a specialization right now. You just need to complete the Ar-Razak program. ठीक है ना?
बिल्कुल जरूर।
Upgrade your resume, apply for jobs, right?
इंशाल्लाह।
So where you're here from Huawei, you can go up and up and up. And तुम जा सकते हो, ठीक है ना? But if you don't, then wherever you're sitting, you'll be sitting there. Automation can only take you this far, but if you have to keep on learning, but then don't stop your learning process. You have to keep on learning new things, right? So keep on doing that, inshallah. That is my
इंशाल्लाह।
recommendation for you. Okay. So
जज़ाकल्लाह
Jazakallah khair. May Allah give you more success. Ask your parents. Parents are alive. Zinda hai?
अल्हम्दुलिल्लाह।
चलो तो दुआ करना, उनसे बोलना, अल्लाह में नहीं सलूक शहादतैन फिल मस्जिद नबी सल्लल्लाहु अलैहि वसल्लम. अपने माँ बाप को बोलो कि खुसूसी मुझे दुआ में याद रखें इंशाल्लाह।
वालिद साहब इज्तिमा के लिए गए हुए हैं अभी, आज इज्तिमा है लाहौर में प्राइवेट में,
ठीक है
उनसे दुआ
इंशाल्लाह,
कर।
दुआ करें इंशाल्लाह।